Well, hi, it's fuel tank time. So what I want to do is take you for a walk around and just show you my CAD drawings and some of the aluminium that I've already started cutting out. Best thing to do is let's get into it and let's take a little walk around, shall we? Okay, so here we go. Okay, just making some adjustments to the camera, just so that we're not reflecting too much light. This is the across the filler cap that we've bought. That's the little rollover valve to allow the air in. This is actually almost very much the same as the standard Healeys, except I've gone for a full screw cap and included the rollover valve into the top. Okay, and this will also allow me to get access to the tank should I need it at any time. Here I've machined the couple of parts already, which is that's the inlet outlet to the pump, fuel pump, and then to the bottom of the tank, okay, with copper tube there. And this is my drain valve, okay, and I've already made a cap for that as well in brass. Okay, so coming to the drawing, this is my complete assembly drawing. I hope that focuses alright. That's probably a bit better. Okay, so there's my fuel tank, pretty much almost exactly the same size as the original. Okay, this here again is to indicate the give me 1-to-1 on the end panels, so that I can just trace that directly onto the end panels for bead rolling. This is the again the end panels of the fuel tank. Right, this is the top of the fuel tank. Okay, there's the fuel filler, and this here will be where the sender is, and this is this valve here. We'll set. The next thing is this is the bottom. Okay, so the sump. Okay, and again bead rolling, mainly for the bead rolling sizes. The baffles will look somewhat like this. Okay, and that's it for the A3 size drawings. And there's my fuel sump. Okay, this part here that I've actually already made, and I've got the connections in brass already for that. This here is my drain plug. Okay, this is the sender. Okay, that's a 1-for-1 ratio. I'm doing that in aluminium to weld to the top of the fuel tank, and also another one in brass for the screws to take hold of. Again, 1-to-1 scale ratio. This is the fuel filler. Again, the same thing. I've got to make one out of brass. The brass is coming. 3mm brass to hold all these screws while I lift it up through the tank and through the filler, so I can do up all the nuts. This is the edge of the sump. Again, just 2 drawings of that, and this is where the sender is, and that sits down into the fuel tank itself. Okay, so just a profile of that. So what needs doing is that I actually need to cut all these out, and I've already started with this. I've got the bottom and the top. Okay, this is my fuel sump here, and they're my bend marks for it, and that's where the hole is for the fuel drain. Okay, so it's just a matter of progressing on and just cutting out, which is actually quite boring, I suppose, but the point is that it helps. The reason I catted the whole thing up is because it shows me the exact measurements that I will need. Otherwise, you know, to stay precisely to the schematic of the whole drawing, and it with that, playing around on, where is it? Alright, this is the assembly drawing. Okay, so the idea is to remain right on spec on that, in the sizing that I've got. Alright. So side view, top view, which you can see through, that's the brass plate, and there's another brass plate here, and then that's the bottom view there. Again, all the strengthener ribs, which I've got to mark out next, once I've cut out all the basic shape from that sheet there. So, and I've got, according to this, about 12 parts that actually make it, and but there's 3 baffles and so on. So this is all my parts, item number. This is the type of aluminium I'm using, which is 5005. The hardness is 34 in 2mm. I'm using welding rod ER4043 because it's good flowing. It's a good flow rod, and the bar, the machining, that's already done, which I did with 6060 T5 hardness, and that came out well because I was actually quite pleased with that, as you can see. That's pretty straightforward. So I just sit that in and then weld around this. That's why I've got quite a thick shoulder, so that I can zip weld around it. And same with the drain plug as well. Okay, so the rest is, I'll put you back on the stand, and the rest is just a matter of looking and watching the progress. The more interesting part to come, I'll just show you as I cut out 1 or 2. The more interesting part will be with the bead rolling once I've marked all that out. So let's see how we go. I'll stop there for a moment. Well, hi. Yeah, I felt that I should narrate this part of it because factory noise is just far too much at this stage. This is the sump, and what I'm doing is just drilling the hole for the sump plug. So I've got a conical drill in there, and just to make a simple, I think it was about a 20mm hole. Okay, just checking for fit, nice firm fit, and yep, happy with that. Over to the bending machine now, and this is again with the sump, and what I'm doing is using the pan brake bender to bend. These are the ends here that I've got for the sump again, and just guillotining those out. I've sped up the whole process from here so that I don't bore you to death. Anyway, so picking up the pieces, pretty old machinery that we've got there, you know, in some of the cases, but it all works well, and it's really very well, yeah, very well maintained by the guys. Again, back to the pan brake to do that second bend on the sump, and as you can see there, I'm using the end pieces to give me the alignment and the angle, which is a fairly shallow angle. If memory serves me, it's only about 13 degrees up. And as you can see, I've overbent a little bit and just hammered it back down a bit. Okay, I think I'm happy with that. Now here I've got brass plate now for these rings. I had tried, and I've got actually, as you can see, 2 rings I'm doing. It's damned expensive, that brass, 3mm brass, and it cost me about $80, and I'm making 2 rings out of that. You can see they're one inside the other, so just to keep wastage down to an absolute minimum. Here I've got a spring-loaded punch, just going around and punching the hole locations. That's a fairly strong spring on that punch, and just using the end of the drill more as a center drill, just to give me a good start so I don't run off, and just to make sure I don't run off with the drill. Now I had made that part, the larger ring, I'd made in aluminium, but when I put the set screws through, I found that the threads were stripping, and that of course I need to bring those up in one batch from the tank, because at this stage it'll be almost closed, and I need to bring all the screws up in one go. Right, and then the larger drill for the appropriate size thread that I'm using. My speed on this is about 4 times the normal speed. 5mm drill for 6mm holes, tapped holes, metric. The brass is lovely stuff to work with, no issues with it at all. I think I got this piece on eBay because I just couldn't find anybody locally that would cut me a piece that small. So luckily eBay, and it came from China, eBay had almost the right size that I wanted. Right, I've got a tapping plug on that, and I'm doing M6, and of course being brass, it doesn't really need any lubrication. All I got to do is try and remember to stay vertical on the 2 planes. Okay, so that's the outside ones done for the outside ring, and this is, I think these were M4. Okay, all good and done. Just test some of those holes, make sure that I'm happy that it goes where it needs to go. The screws fit. Yep, all good. Alright, I'd already done the first hole in the hole saw, as you can see. If you notice, I've screwed down the 4 corners of the plate to a piece of timber, and here I am on my second hole saw. I looked at different ways of cutting it. I looked at cutting it on a lathe. I looked at plasma. Plasma's too dirty. I wanted a nice clean finish, and settled on hole saws. And so I'm quite pleased with that. That was a good decision. Using plasma, I would have had to jig it, and you have a habit of, with smaller holes, of tripping and going off location. As it was, again, I got these hole saws pretty much the right size of it. The red ones are the only ones I needed extra. The rest I've got as my own set, and then I found that the shed had some as well. But the red ones actually, they're quite cheap actually. They're about $20 each. Right, and here we go into the last hole. It's 140 mil diameter, and then I started getting problems with the drill. If you notice that drill head is just dropping off, and the Morse taper is just separating, which right in the middle of a job is terribly frustrating. And no matter what I did, I couldn't get the Morse taper to sit. So I'd get going a bit, like you can see here, and then end up with problems right towards the end of this cut, where it really just started playing up. And I've tried to cut out most of the messy cutting, and had to decide in the end to take that chuck, the Morse taper, take it home, rework it, and so that's I took it home for a week, pulled it apart, cleaned it up, and also I'll use some bearing Loctite to lock that in. So I actually go back tomorrow, so that's the first thing I'll do, is put that head back in. So this is just finished the job, a little bit on the frustrated side, but in the end I got there, and the rest of the shed has been without a drill press for the rest of the week. Not that there's much activity. Right, and then finally we get through. Now, so there's my end result, all the screws. They're stainless screws, of course, and they come up through the tank and then through the filler, and help me to hold all the screws in one go as I pull them through, and then put nuts on the outside. That's the sender, for the sender, so I've yet to order a new one of those, sender that is, and but anyway, I'm very pleased with that. It came out well, so it's all right, it's all accurate, and it's spot on, and that's it.